the signal in figure P3.3-7 are modulated signals with carrier cos 10t. Find the Fourier transform of these signals using appropriate properties of the Fourier transform, and table 3.1. Sketch the amplitude and phase spectra for figure P3.3-7a and b. Okay, they're asking us to sketch the amplitude and phase spectra. Okay, and these functions can be expressed in the form gt cos 2phi f naught t. There's a hint also provided. Okay, so let's go ahead and do that. So first let's deal with the a part, and they have provided that these functions can be expressed in the form of g of t cos 2phi f naught t. So I'm going to go ahead and do the signal. The signal can be expressed as follows. M1 of t is equal to g of t cos 2phi f naught t. So first we have to look at this look at this given diagram and see how many periods we have. Periods is like to complete full cycle. Okay, so here I'm seeing 1, 2, 3, 4, 5 here. Okay, if I start from this 0, we can see how many. So 0 to 5, let's see. It's starting from the top 1 and then 1 cycle over here. So 1, and then 2, and then 3, and then 4, and then 5. So totally 5 cycles. So we can say there are 5 periods of cosine function. Cosine function in an interval phi. Hence, the period of the cosine function, the period of the cosine function in the given signal is t naught is equal to phi divided by 5. Okay, this is the period. So if we have the period, we can find out the frequency. Find the frequency of the cosine function. Frequency of cosine function. Now, frequency is given by f naught is equal to 1 over t naught, and we already know the t naught, that is 5 over 5. So this is 1 divided by 5 over 5. So this 5 flips and go to the top, so we will get 5 divided by 5. This is our frequency. Okay, now let's go ahead and continue in the next page. Okay, so here Now we know that m1 of t is equal to g of t cos, what do we have here? Here we have g of t cos 2 phi f naught t. So cos 2 phi f naught t. Now what we are going to do is, if we have found out the f value, so we can replace this f naught with that one. We found out that f naught to be 5 over phi. So this f naught we can replace that with that. So if we do that, it's going to be g of t cos 2 phi. Instead of f naught, I put 5 over phi and t. If we, and these values are inside of this cos function, and if you do that, this phi cancels, and then we get cos 10t. Okay. So we can say this is g of t cos 10t. And also, if you look at this first graph is a triangular shape. Okay, so we can say that from the sketch, of the given signal, g of t is equal to triangular t over 2. Okay, now the overall signal is m1 of t is equal to g of t cos 10t. So instead of g of t, we found out that it's triangular t over 2 phi. So we can place that triangular t over 2 phi cos 10t. So now we can go ahead and do the Fourier transform of each of these things. When we do the Fourier transform, we have to know some properties. So let's look at the first one. Consider the following Fourier transform pair. Okay, so if you have a triangular t over tau, and if we do the Fourier transform of that, that one become tau over 2 sin square omega r divided by 4 omega tau divided by 4. Now what do we have here? Here we have triangular t over 2 phi. So we have to do the same thing for that. So if I put triangular t over 2 phi, and if I do the Fourier transform of that, here we have tau on the bottom, that comes to the top. So here we have 2 phi on the bottom, that comes to the top. So 2 phi divided by 2, 2 cancels, we will end up with phi right here. And then sin square remains the same. And then we have omega multiplied by tau. Tau is, in our case, that's 2 phi. So multiply by 2 phi divided by 4. 2 and 4 cancels. So we will get omega phi divided by 2. Okay. So this is what we get for the Fourier transform of t over 2 phi. Now we have another part left in our equation. This is the equation we are looking at. So m1 of t is multiplication of this triangular t over 2 phi and the costant t. Okay, we have taken care of this one, and then we have costant t left. Now we have to do the Fourier transform of that. And one of the property in Fourier transform, this says that if you have cos omega naught t, and if you do the Fourier transform for that, that is equivalent to phi multiplied by delta of omega minus omega naught plus delta of omega plus omega naught. Let's look at what we have here. Here we have cos 10t. So cos 10t, do the same thing for the cos 10t. So wherever we have omega naught, we replace that one with 10. So the Fourier transform of this is going to be phi delta and then omega minus 10 plus delta omega plus 10. And that's the Fourier transform of cos 10t. Now we have these two, and we have to do one more property, like when we multiply two of them. So we have found out, we have taken the Fourier transform of this, and we have taken the Fourier transform of this. And when we multiply two functions, this is one of the function and this is another function with t. So if we multiply two functions with t, let's say x of t times y of t, and the Fourier transform of that, okay, for this one I have to put f here. Fourier transform of that become 1 over 2 phi x omega convoluted with y omega. So if we apply same thing for the function we have the function that's triangular t over 2 phi cos 10t, and if we do the Fourier transform for that, then this one become 1 over 2 phi automatically comes into play, and then we will have the functions that we derived. First function we derived is phi sin square omega phi over 2, phi sin square omega phi over 2, and that one convoluted with the one we derived for the cos, that is delta omega minus 10 okay, and there's a phi in front as well. The phi comes right here, okay, omega minus 10 plus delta omega plus 10. Okay, now we have all this. Now we have to simplify this one. So to do the simplified of this one, we have to do the convolution. Now let's go ahead and do it in the next page. Okay, now the Fourier transform of m over t. Now the Fourier transform of m1 of t is m1 of omega is 1 over 2 phi sin square omega phi over 2 convoluted with phi delta omega minus 10 plus delta omega plus 10. I just copied the one we written before. Okay, this is 1 over 2 phi sin square omega 2 phi over 2 convoluted with phi delta omega minus 10 plus delta omega plus 10. Okay, now we have this. Now the next step is we have to do the convolution. When we do the convolution, what we do is we multiply individual term, but before that we can get rid of this phi. If we take this phi and this phi along, this phi square, so phi square divided by 2 phi, that's basically phi over 2. Okay, phi cancels and we will get phi over 2. And then when we do the convolution, so phi's are gone because I took this phi and this phi and put the phi square, then phi square and phi cancels, so we get phi over 2. So the phi's are gone. Now we have to only deal with this sin square and these delta functions. So when we do the convolution, the first term is going to be sin square omega phi divided by 2, and this one is going to be convoluted with delta omega minus 10 and then plus again the sin square omega phi divided by 2, and that one is going to be convoluted with delta omega plus 10. Okay, now after we done the convolution, we are going to end up with m1 omega, and then phi over 2 remains the same, and then sin square when we do the convolution, the delta will go away, so we will end up with omega minus 10 and then phi here divided by 2 and plus sin square omega plus 10 phi divided by 2. Okay, so this is the answer for the first part. This is the Fourier transform. Now they have also asked to draw the magnitude and phase diagram. So here they have mentioned that sketch the amplitude and phase spectra. For the amplitude diagram, we had to find out the equation magnitude equation, and the phase spectra, the angle. Okay, now let's go ahead and do that. So magnitude and phase. The magnitude and phase. Okay, for the magnitude, we have to just put m1 of omega and then the magnitude. So if you put a magnitude for this one, since we don't have any shift or anything, it's gonna remain the same. We are gonna get the exact same function for the magnitude. That is phi over 2 sin square omega minus 10 phi divided by 2 and then plus sin square omega plus 10 phi divided by 2. Okay, that's for the magnitude. And the phase, there's no shift or anything, so the phase is going to be 0. Okay, let's go to the next page. Now we have to draw the diagram. So since the phase is 0, phase is 0, there is no phase spectrum. Phase spectrum, the magnitude spectrum is the magnitude spectrum is it's gonna be like this. Okay, so what you're gonna have is you're gonna have a diagram like this, and the height of this one is 5/2. Another one, the height is 5/2 for both of them, and this one is m1 of omega, and here this one is -10 and this one is +10. This one is omega, and that's it. This is the magnitude spectrum. Okay, there's no phase spectrum, so that is it for the A part. Now let's look at the B part. Okay, here we have done with the A part. Now we are going to do the B part. If you look at the B part, that is exactly like A, but shifted how many units? 2 units to the right. You notice initially it was -5 here. Now the initial point is at 5, so it shifted 2 units to the right. So based on that knowledge, we can deal with this. So this signal is shifted version of signal, shifted version of signal in part A, So m2 of t is basically m1 of t minus 2 because it's shifted by 2 units to the right. So if we apply the Fourier transform, then m2 of omega is basically, if you multiply, if it's shifted 2 unit to the right, that is equivalent in Fourier transform like multiplying by e power minus j2 omega. If you multiply this one with the Fourier transform we found here, this is for the first one, we found the Fourier transform. If you multiply that one with this, that is the Fourier transform is m2 omega. So we just try to multiply whatever we derived here. For the first one, we derived this, right? 5/2 sin square omega minus 10 5/2 plus sin square omega plus 10 5/2. This is what we derived, and if you multiply that one with this e power minus j2 omega, that's our Fourier transform. So the answer here is e power minus 2 omega multiplied by 5/2 sin square omega minus 10 divided by 2 plus sin square omega plus 10 divided by 2 and 5 divided by 2. Okay, so bracket. Okay, that's our and this is, there should be j also here, j to 5 omega. So if we do that, this is equal to m2 omega. This is the Fourier transform. And here, can we simplify this one furthermore? Let's see. Okay, one thing I had noticed here, this 5 by 2 is multiplying the whole thing. So it means we can take the 5 by 2 to the front as well. So the final expression, so let's see, the bracket is in the right positions. Yes. But this outside, okay. So what we can do here is, so it should be another bracket right here. Okay. So what we can do is we can combine this e power minus j2 phi omega and phi over 2 together, because this is common for everything. So if we do that, this is going to be phi e power minus j2 phi omega divided by 2, and then other terms multiply, that is sin square omega minus 10 divided by sin square omega minus 10 phi divided by 2, and then plus sin square omega plus 10 phi divided by 2, one bracket for this and the other bracket for the common everything. And now we have derived the Fourier transform of the part B. The next thing is we have to find out the magnitude spectrum and the phase spectrum. The magnitude spectrum, let's look at that. The magnitude spectrum is, if you take m2 omega and put a absolute value for this, then there will be no shift to any phase. So this is going to be similar to the first Fourier transform, that is phi over 2 sin square omega minus 10 phi divided by 2, and then plus sin square omega plus 10 divided by 2, and then multiply by phi over here. And that's it. And this is magnitude spectrum. So we can mention here as well the magnitude and phase are. So first I derive the magnitude, that is this, and the phase is m2 omega, and here we have a shift of 2 phi to the left by, to the right by 2 units, 2 phi units. So this is minus 2 phi omega. Okay, now since the magnitude spectrum is same, the graph is gonna look exactly the same as before. So it's gonna be like, we are gonna have this height, and then another one, another one exactly like that, and this is minus 10, and this one is plus 10, and the height is 5 by 2, and this one is m2 omega magnitude, and this one is omega, and this is 0. Okay, this is magnitude spectrum diagram, and the phase spectrum is going to be a straight line. So if I draw that, I'm going to go and do it on a new page. And the phase spectrum is going to look like the negative straight line like this, and this is 0, and this one is omega, and this one is phase of m2 of omega. Okay, so that's it for the B part. Now let's look at the C part. Okay, C part, let's look at the diagrams. For C part we have this diagram. If you look at initially, we have, for the A diagram we have a triangular shape, for the B also we have a triangular shape, but for the C part we have a rectangular shape. If you put dot dot and draw the line, it's going to be rectangular shape, so this is going to be a little bit different. Okay, let's express this, but the expression is same for everything. G of t equals 2 phi f naught t. That's the expression we are going to have. So we can mention here the signal can be expressed as follows. And that is m3 of t is equal to g of t cos 2 phi f naught t. So let's look at the periods. Okay, for this one we had from 0 to 5 we had 5 periods. Now here we have 5 to 3 5. Let's count all of them. So if I start from here, this is 1, this one is 2, and this one is 3, and this one is 4, and this one is 5, this one is 6, this one is 7, this one is 8, this one is 9, and this one is 10. Okay, so totally 5 2 3 5 we have 10. Let's count again. 1 2 3 4 5 6 7 8 8 9 10. So 5 2 3 5, so it means in the 2 5 interval we have 10 period. We have mentioned that one here. There are 10 periods of cosine function in an interval 2 5. Hence, the period of the cosine function in the given signal function in the given signal is t is equal to 2 phi divided by 10, that is pi over 5. So if we know the period, we can calculate the frequency, find the frequency of frequency of cosine function. The f is equal to 1 over t naught. 1 over, this is t naught, 5 over 5. 5 over 5, this 5 flips and go to the top, so we get 5 over 5. This is our frequency f naught. Now let's deal with the function provided to us, that is, okay, now m3 of t is g of t equals to phi f naught t, and for the f naught we are going to replace that one with 5 over 5. So this is going to become g of t cos 2 phi multiplied by 5 over 5 t. So 5 cancels. We end up with a similar to one we had before, that is cos 10 t. Okay. Now we have that, and also we know one more thing, that from the sketch of the given signal, okay, we know that this g of t is basically rectangular t over 2 phi. Okay, how do we know? Because if you look, previously we had triangular, here we have rectangular step. Consider, so let's do the Fourier transform. Consider the following Fourier transform pair. Okay, for a rectangular, if we had a t over tau, the Fourier transform of that one comes like this: r sinc omega t divided by 2. What we had for the triangular. So previously we had for the triangular, that is, if we had a t over tau, we had tau over 2 sinc square omega tau over 4. But here for the rectangular it's different. This is okay, this is tau sinc omega t over tau. Okay, omega tau over 2. Yeah, erase this. Omega tau over 2. So that's the difference between, like, if you have triangular, you're going to have different thing. When you have rectangular, you're going to have different thing. That's the thing that notice here. And what do we have? We have rectangular t over 2 phi. 2 phi. Okay. So instead of taus, we replace one with 2 phi. So the Fourier transform of this one is going to be 2 phi sinc, and then omega, instead of phi we are going to have 2 phi divided by 2. So 2 cancels, and we are going to have phi here. And the cos omega naught t is going to be exactly the same as before. previously we have seen that if you have cos omega naught t, the Fourier transform of that becomes phi multiplied by delta omega minus omega naught, and then plus delta omega plus omega naught. Exactly same for this, because the only difference we had is rectangular. We dealt with this already. This cos function remains the same, and what we have is cos 10t for our function. We derived that one over here, cos 10t. So instead of omega naught, we replace those things with 10. So this is going to be 5 multiplied by delta omega minus 10 plus delta omega plus 10. Okay. Now also we have to know that when we multiply two functions with t, we have a g of t function and a 10t. Yeah, I had to express one more thing, that is we are multiplying these two, right? I don't know, did I express that? No. So let's do that here. M3 of t is multiplication of this rectangular t over 2 phi multiplied by cos yeah, another thing I had to do here is there's a shift as well. There's a shift of 2 phi. Okay, so that one we can do it here. So before I do that, let's do the shift also, because if you look at this, initially we have minus phi, right? And if we move to the phi, so it means we shifted phi. That if we shift phi, that comes to 0. If you shift 2 phi, that comes to phi. So if you are starting from phi, then there's a shift of 2 phi. So we have to do that one here. Since the overall signal is shifted by 2 phi, the signal can be defined as the signal can be defined as m3 of t is equal to g of t minus 2 phi, and then cos 10 t minus 2 phi. Okay, now we can express our function. We have g of t minus 2 phi is going to be basically rectangular t minus 2 phi divided by phi divided by 2 phi, and that one multiply with cos 10 t minus 2. Okay, so this is the one we have to do the for this one we have to do the Fourier transform. So we have found out the Fourier transform of rectangular t over 2 phi, that is this, and also we have found out the Fourier transform of cos 10t, that is this. And also we have to know that when we multiply two functions with t, like for example, if I have a function x of t and a function y of t, if I do that, the Fourier transform of that one is there will be automatically 1 over 2 phi over there, and then we will have x of omega convoluted with y of omega. X of omega is the one, for example, if we have rectangular function, we have rectangular function and a cos function. So the Fourier transform is this. So this value is going to be replaced by this, and this value is going to replace by this. Okay. So what we're going to have is, what's the function we have? We have, like, without the shift, we had this rectangular t over 2 phi cos 10t. Okay, this is the function without the shift of 2 phi. So the Fourier transform of that one is basically 1 over 2 phi, and x omega is going to be 2 phi sinc 2 phi sinc omega phi, and that one convoluted with this one, the cos 10t, that is phi delta omega minus 10 plus delta omega plus 10. Okay, that is without the shift. Now we have a shift of 2 phi. Okay, let's write that. Well, let's see what happens. Correct. So this one, t minus 2 phi divided by 2 phi, and then cos 10 t minus 2 phi. So if you have a shift of 2 phi, then we just try to multiply this one with e power minus j 2 phi omega. And others remains the same. So the bottom part is 2 phi here, and this one is 2 phi sinc phi omega convoluted with phi delta of omega minus 10, and then plus delta of omega plus 10. Okay. I'm going to go to the next page and simplify this. Okay, so that's all we have. So now the Fourier transform. Now the Fourier transform of m3 of t is m3 of omega. That's equal to the shift of 2 phi, that's e power minus j 2 phi omega divided by 2 phi then 2 phi sinc phi omega convoluted with phi times delta omega minus 10 plus delta omega plus 10. Okay. Let's see if we can simplify something. So when we multiply this 2 phi and phi, we are going to have a 2 phi square. So 2 phi square over 2 phi. So 2 phi and 2 phi square cancel, and we end up with a phi on top. And that one will be multiplied with e power minus j 2 phi omega. And others, we are going to have convolution. So we have taken care of this 2 phi and the phi. So others are the one that's going to be convoluted. So we are going to have sinc phi omega multiply convoluted with delta omega minus 10, and then plus sinc phi omega convoluted with delta omega plus 10. So that's going to end up with, if we do the convolution, we are going to end up with y e power minus j2 for omega, and this is going to be sinc omega minus 10 pi plus sinc omega plus 10 pi. Okay, and that is basically it. Yeah, that's our Fourier transform of the third one. Now we have done the Fourier transform. What else left? We have the graph for the phase diagram and the magnitude diagram and the phase diagram. The magnitude diagram is going to be same as before, not same as before because what we had before. Let's see. So this is the one we had. We have 5/2 sinc square and stuff, but here it's going to be a little bit different because we have dealt with the rectangular one. So the magnitude phase is going to be magnitude and phasor. The magnitude is going to be absolute value of m3 omega. When we do the absolute, the shift will go away. So we are going to have this expression without the shift. The shift is e power minus j2 for omega. That will be gone, and whatever else left is going to be remain. This is going to be 5 times sinc omega minus 10 pi plus sinc omega plus 10 pi, and that is it. This is for the magnitude spectrum, and we need to know the phase spectrum, that is m3 omega, and here we had a shift of minus 2 phi, so this is going to be minus 2 phi omega. Okay, finally we just have to draw the diagram. Okay, so for this one, the diagram is going to be little looks similar to the one before. Here you see we have this, but the only difference we are going to have is now this is gonna go like a cos wave, cosine wave with the x-axis, and then gonna go with the height. So we are gonna have the same thing in the opposite side as well. The height is gonna be 5/2. And this distance is -10, and this one is +10, and this one is omega. For the phase spectrum, we are going to have the exact same thing, that is a negative line like this, and here this one is m3 of omega magnitude, this one is phase m3 of omega, and this one is omega, this is 0. And that's it. That's how we can do this kind of problems. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.